So the first example I'm going to do here is this right here. Okay. And so this is a skeletal structure, and the way to read this is when you look at this shape here, every side right here, this is a carbon. This right here is an oxygen, so there's no carbon there. And any two intersecting lines, there's a carbon if it's not written there. And also here, there's a carbon. Okay, so intersection of two lines, is a carbon right here. And also this is a carbon as well on this side and that. Okay, so to write this, so this is carbon, outside carbon, and we all know that carbon likes to connect to 4 hydrogen, mainly 4 bonds. So since this line right here is already a bond between the carbon and oxygen, then this carbon is going to be connected to 3 hydrogen. So therefore, when we write the formula, it's going to be CH3, okay, for this carbon right here. Now this is an oxygen, we know, so we're going to write that down. But this carbon right here has, if you see, 2 bonds already, which is 2 lines. You always count the lines and see how many, so how many bonds does carbon make? It makes 4 bonds, so it needs 2 more hydrogens. So what you would write is CH2 because it's in the middle. And pretty much any carbon on the end of a chain is going to be connected to 3 hydrogens. So that one would be CH3. Okay. This would be the formula from this skeletal structure. Let's do another example. In this example, we have, let's say we have a triple bond here on this. So we're going to write what's going on, how many carbons we have, okay? So we know that there's a carbon here, okay, intersection of 2 lines here. This is just the triple bond, okay? These are going to be carbons. And there's a carbon here, okay? So for us to write the formula, we need to see, okay, this carbon, how many lines does it have? It has 1, 2, 3. So it has 1 other bond, which makes 4, and that's going to be your hydrogen. So it's going to be CH, okay? Now for this carbon right here, the second one, how many lines does it have? 1, these are all bonds. 2, 3, 4. It already has 4. It does not need any more hydrogen, so it's going to be just carbon. And this one at the end, just like I said, mostly is going to be CH3 because it already has 1 bond, and these hydrogens never show on skeletal structure. I'm only showing it for the sake of teaching you what it should look like. Okay, so this is equal to that. right here, this whole thing. Okay, let's do another example just to get a hang of this. All right. Let's go the opposite way and see if you can do it. Stop the video and try to see if you can figure it out. CH3. Okay. So first thing you do when you have this formula is see how many carbons you have. 1, 2, 3, 4. That is more likely going to be your main chain. Okay. So we're going to put 4 in our line. So we have 4 carbons. Okay, just an easy way to do this. When it is 4 carbons, you're going to make 3 lines. Okay, so that you don't make a mistake when you're doing a test, you do it faster and you didn't take a lot of time. So we have 4 carbons. We're going to draw 3 lines. 1 line, 2, 3. That's going to be 4 carbons. 1, just to make sure, 2, 3, 4 carbons. Okay, now let's see if we have the right amount of hydrogen. This is just for the sake of showing you. You don't put the hydrogens on the skeletal structure. So this first one is going to be CH3. Always the outside carbon will have CH3, right? So this carbon right here is going to be this one, but it has 2 lines, 2 bonds here and here, right? But there's an oxygen. This oxygen, we're also going to put it here to make the 4 bonds, okay? Anything that you see that has a parentheses like this, it's going to be a substituent. So let's look at the next carbon. Next carbon right here is going to be connected to 2 hydrogen because we already have 2 bonds, 2 lines. And then this carbon right here has 3 hydrogen. So this is how you go from here to here. Let me draw another cleaner one for you. Okay, this is how you draw the final answer for that. Let's do another example, and this is an exception to all of them. Okay, so we have this. Okay, this is a chlorine. It is not a carbon, so you don't count from there. This is a carbon. This is a carbon. This is a carbon. This is not a carbon. This is a hydrogen. Anytime you see a double bond with an oxygen at the end of a chain and a hydrogen, know that it is an aldehyde. Okay? All the time. For some reason, it's just going to be written that way no matter what. So let's write the formula for it. So like we said, this is going to be a carbon. We have our carbon. This carbon has 3 bonds already, so it's going to have one other H, so it's going to be CH, right? Now this one, second one, has 1, 2, 3 lines already, so it's going to also have another CH, right? And then this carbon already has all of its 4 bonds, so you're only going to write a C, a carbon, okay? And then you're going to just write it as it is. When it is an aldehyde, you just write the CHO. Note that this is always going to be CHO aldehyde. And then don't forget about this chlorine, okay? To also add it in. I just wanted to focus more on the main chain, okay? So we have 1, 2, 3, 3 carbons. We also have 1, 2, and 3 carbons, okay? And we have our aldehyde at the end right here. So this is the only exception for skeletal structure here. Okay, let's do more examples. Maybe a little bit hotter. Please stop. Feel free to stop the video before I start working on it. Okay. So let's look at number 1. Okay, so number 1 here, I'm just gonna draw really small underneath. Okay, now we have, let's see how many carbons we have. We said that parentheses are going to be substituents, right? So we have 1, 2, 3. Let's skip the substituents for now, okay? 3, 4, and 5. Okay? Now, let's start drawing the structure. Okay. So we said 5 carbons. This is just something if you want to do to make sure you save time on a test. Just do it more faster, okay? So we're gonna put 4 lines. You always minus 1 and you get 4 lines. So 1, 2, 3, 4. We have 4 lines. And to make sure, 1, 2, 3, 4, 5. Those are the carbons on the main chain. Okay? So the carbon that is gonna be on okay, so this one is gonna be this right here. It's gonna be attached to 3 hydrogens, right? This is gonna be here, 2 hydrogens, because it's in the middle and it already has 2 bonds. This carbon right here, this guy, is going to have substituents, right? Because it's only by itself. So the substituents, we're going to have CH2 and CH3. So that's going to be like this. this is going to be CH2, right? Right here, this carbon. And this is going to be your CH3. Just for you to see what I'm talking about. And the next substituent is going to be off of the same carbon, because again, we have 3 bonds here. This carbon is alone, doesn't have any H, any hydrogen. So this is also a substituent coming off of the same carbon. So that is going to be like this. We're more flexible when it comes to alkanes, so don't worry too much about how do you draw it. Okay, so the next one, this point right here, it's gonna have 2 hydrogens, and then the very last, again, like we said, that it will always have 3 hydrogens because it only has 1 bond instead of 2 in the middle here. Okay, let me write it in a cleaner way. Okay, so we said 5 carbons, 1, 2, 3, 4. That, like that. Okay, and there you go. So, and one more thing, this is this right here, just to make sure you have it. It's gonna be CH3. So this is the final drawing of that. Okay. Now let's do the next one. See if we can find some space here. Didn't think it was gonna be that big. Okay. This one is a little bit tricky. Let me write it. Let me rewrite it here bigger so you can see what I'm doing. CH3. Okay. All right. So we have these parentheses here and here. So these are going to be substituents, right? This is your main chain. Your main chain has 2 carbons. So because it would have 2 carbons, it's going to be like this. Your 1 carbon here, 1 carbon here. And you know that each carbon is going to have 2 of CH3s. 2 of CH3, each carbon. Okay? So this carbon will have 2 of CH3, so that's just going to be like this. Right? Remember that CH3 will be at the end and it will be connected to 3 hydrogens, right? And then the same thing goes for this carbon, and it's gonna have 2 CH3s, and it's gonna be connected to, also each one is gonna have, it's an end carbon, it's gonna have 3 more hydrogens that will not show. And let's do a cleaner structure here. This is what it's gonna look like. That's the answer for that one. Okay. Now let's do this one right here. Okay. Now, like we said, first thing you do is count the amount of carbons on your skeleton. So 1, 2, We're not counting this. The parentheses is substituent. 3, 4, and 5. So 5 carbons again. Okay, that's 4 lines. Let's write 4 lines. 1, 2, 3, 4. All right. Let's look at the first carbon. It's going to be CH3, right? Now this carbon right here only has H, so that's 3 bonds, right? Now it's going to be connected to this OH to make the fourth bond. Remember, it's a substituent, right? Let's do this one. It's going to have, again, it has one H, but it has a substituent. So we are going to put CH3, and remember, this is a carbon. The end is connected to 3 other hydrogen, right? And then this carbon right here already has 2 bonds. So CH, another H. And the very last carbon we drew here, CH3. So let's draw a cleaner version of this. This is your final answer for that. Okay. I hope you learned something with me today. I will be doing more videos answering questions like these. I hope you like it. I hope you learned something again. All right. Thank you for watching.